All right. Congratulations on finishing your quiz. Here we go with the next lesson. We're kind of winding up this chapter. There's this one, and then I think there's just one more. All right, it's about scale drawings and models. It's a little like practical application, or like one of the most common ways you're going to see this in other classes, or just kind of in real life. All right, so a scale model is called a scale model because we've used this scale factor to probably reduce the real life situation, such as a map. The scale of a model or drawing or map is the ratio of the length on the model or drawing to the actual length in real life. All right, such as this. You get these little maps, and it tells you somewhere on there what the scale of the thing is. It says here 0.4 inches is equal to 40 miles, which is kind of a bizarre one, but this is geometry class, and we're equipped to handle bizarre situations such as this. All right, so find the actual distance from Nashville to Memphis. All right, so I get a ruler out, and I try to measure that. I notice if I try to do this on here, okay, so here's Nashville up here, here's Memphis down here. If I try to measure that with this ruler, I notice it's quite a bit different than if I use the printout version, so I'm going to not use this one. If I use the printout version and I measure that length, I get right around, oh, sorry about that, I get right around 3.2 inches. That's not the answer, but 3.2 inches is what I see. So I know on the scale, they tell me 0.4 equals 40 miles. So I can just set up this ratio. 0.4 inches is to 40 miles, like 3.2 inches is to what? And I just go about doing that. I guess I don't need, oh gosh, that moved. Let me fix that. Sorry, straight right click there. So I can just solve this proportion. And this, of course, is what we've been doing all chapter. 0.4 x equals 40 times 3.2. Do that on the calculator. And I get 128 on this side. So divide that by 0.4, and I get 51.2. So the actual length here is 51.2 miles. That doesn't seem right. Oh, I know what I did wrong. Divide 128 divided by 0.4. Sorry, you're going to get 320 miles. Okay, that looks right. Gosh, we probably could have done that in our head earlier. Why did they say 0.4 inches equals 40 miles? Why didn't they say 0.1 equals 10 miles? Then we would have been able to do that earlier. Anyway, find the actual distance between Nashville and Chattanooga. All right, so from Nashville to Chattanooga, I see this over here. I use the real version with the real ruler. I get about 1.0 to make this easier. I'm going to say like 1.8 inches. So I get 1.8 inches in real life up there. I'm going to do this here, and I'm going to write this one here. This was 3.2, just so we know what that came from. All right, so again, 0.4 is to 40 as 1.8 is to what I'm looking for. Save some time, do some algebra, and I get my pencil somewhere. Yeah, I get 180. So I get 180 miles. And you know what? We should probably start to be looking for these because this is kind of, like real life problems. Okay. Example 2, scale models. So this is like the 3D version of that, but same kind of thing. This one I don't think we need the ruler for. If we're told that the length of the model is 6.5 inches, but the actual car is 13 feet long, we can use that as a ratio. We could say 6.5 inches to 13 feet is the scale, or is the ratio of lengths. When they're asking what's the scale of the model, they don't necessarily want you to be able to do it like this. Like you don't want to use different units though. 0.4 inches equals 40 miles. I mean, it's not really, I guess it's not really wrong to say that. I'm just sure that in our book, that's not what they mean by scale here. They want you to go a little further than that because this is a little bit too easy. Let's make this a little more manageable for the average user. 6.5 inches to 13 feet to kind of make that, I don't know, like we're reducing a fraction. If I put 6.5 inches and change that to, notice what happens here. Because I know 6.5 is half as big as 13. So, I don't know, to make that, to reduce that as a fraction, I know that's the same as like 13 inches is to 26 feet. Just watch what I do here. Because I know this fraction is half. I guess I really need to do that. I know this is going to be the same thing as 1 inch to 2 foot. See how the half is still kind of there? I feel like reducing this fraction by itself and leaving the units as they are that's kind of nice because now if I needed to, I could say this 1 inch, and then instead of saying 2 foot, I'm going to say 24 inches because that's what 2 feet is. That's or 1 inch to 24 inches, and that I can also write that as this, and this is what you see a lot with scale models: 1 to 24 with the little ratio colon in there. I could have also done that this way: 6.5 inches to 13 feet. I could have gone something like this: 6.5 inches to 13 feet in inches, which is 13 times 12. And if I took that and put that straight in my calculator, oh, watch this. Remember, control divided by gives you that. If I went 6.5, and you can actually just do this, 13 times 12. This will probably give you a decimal, which is not what I want in ratio land. To change that to a fraction, you can do this. Menu number approximate to fraction, and that usually gives you exactly what you want if it's a nice fraction. Yeah, so there it is, 1 over 24. So 1 over 24 is the scale I'd want there. And realize, yeah, this would be in inches. So that's probably a better way to do it. You can write that this way. I kind of like that better. How many times as long as the actual car is the model? Well, now I have the answer for that. What will we accept for this answer? I would accept that. Oh, black highlighter. That's really kind of ominous, isn't it? I would accept this. I think that's okay. I don't know if I'd take this. This doesn't show scholarly application. I like that the best. Of course, I would take that. Either one of those is fine. Yeah, that's really the same thing, I guess, isn't it? Not sure what you'll find in the back of the book, but I think I would take any of those. That'd be okay. All right, Tanya's making a scale drawing of a room on an 8.5 by 11 inch paper. That's pretty much the size as A4, but that's the size you find that's comparable in the US. If a room is 14 feet by 12, what's the best she should use? Okay, so she has this piece of paper that is 8.5 by 11, and it's got to fit on there. And you don't want to go right to the edges, and you want it to kind of be an easy scale factor that's nice to remember, like 1 to 6. You don't want it to be like 1 to 6.2, like it's kind of weird. Her room is 14 by 12. Gosh, why do they do that? Her room is really 14 by 12. And so let's line this up. So this is the long side and this is the short side, 14 to 12. Now these rectangles aren't similar. So it's not going to work out perfectly that this is going to work. I just need to make sure that the biggest dimension fits in the biggest side and the smaller side fits in the smaller side. Right now, the bigger problem is going to probably be the 12 fitting in the 8.5. That's just my estimation. But let's see what we should do here. If I took everything here and divided it by 2, okay, first of all, these are feet, and these are inches. But really, the relative size of these things is kind of the same. It doesn't really matter. Like, I could do a 12-inch by 14-inch model, and that would, of course, work perfectly for the 12-foot by 14-foot if I went 1 inches to 1 foot. But that's not going to quite fit on the 8.5 by 11. If I divided these by 2 and went a little further and went to 6 by 7, that would fit on there. But that's kind of too small. I don't think I have to go that far. Now, it just says make an appropriate scale, so it doesn't have to be perfect. So I think 1 inch to 1 foot is probably, of course, not going to work. 1 inch to 2 feet is going to be a little too extreme. So 1 inch to 1 foot is not going to work. 1 inch to 2 feet. Think about what that would do. That would give us here, I think it would be inches. It would be 6 by 7, and I think we have more paper we could use a little bit. So let's go halfway in between. I think a lot of this is just estimation. Let's go 1 to 1.5 feet. So that would be 18 inches. Yeah, so I think that would be pretty good. 1 inch to 18 inches. So let's use a 1 to 18 scale model, and then find the dimensions of the drawing. So if it's 12 feet, so our scale is 1 to 18. So 1 inch in the scale drawing land equals 18 inches over here. We want to know what's the 12 feet turn into in this ratio. So little is to big as little, we don't know what that is to big. And it's 1/18. So if we do that, we find that we get x is equal to 2/3. Now remember what units we're dealing with here. This is probably going to be the hardest part of this unit, or this lesson. We were using 1 to 18 as a scale drawing factor. That means 1 inch over here stands for 18 inches over here. That also means if we found 1 foot over here, it would stand for 18 feet over here. Or 1 centimeter would actually even mean 18 centimeters over here. So it doesn't really matter what units we're dealing with. The ratio is a ratio is a ratio. I put in that as a ratio, 1 over 18. That equals x over 12, and that's supposed to represent 12 feet. So 12 feet is supposed to represent come out as 2/3 of a foot in the drawing. 2/3 of a foot, so it's probably good to keep track of these units. So this was 12 feet. 2/3 of a foot is the same as, if you think about it, 8 inches. So that's the smaller dimension. The other dimension is going to be x out of, maybe I should use y. This is the length. Y out of 14 feet. And I do that again, I'm going to get 14 feet equals 18y. I'm going to get a decimal amount of feet here. 18 divided by 14. I'm not going to pause it this time because I'm so close. Oh, come on. Calculator not cooperating. I'm going to get 1.28. Oh, wait, I did that wrong. 14 divided by 18. I'm going to get 7/9 of a foot. 7/9 of a foot. Let's go ahead and write fractions. You guys don't mind fractions, do you? Which in inches, 7/9 of a foot times 12 equals 9 1/3 inches. So by using this crazy scale I brought up, which is 1 to 18, I get this dimension that's 8 by 9 1/3 inches. And that takes up our 8.5 by 11 paper pretty good. First of all, the 8 and the 9 1/3 fit inside these dimensions, and they really kind of maximize the page. I think that's pretty good. All right, that's it for this unit. This is kind of crazy in terms of keeping track of the units, so make sure you keep those straight all the time, and we'll see you in class.